Okay, factoring. This is part 1. Our notes will probably be in 2 separate notes this time. So this will be part 1. And the point of factoring is doing backwards what we were doing when we were multiplying polynomials. So typically on factoring, you're going to be given a trinomial, which means something with 3 terms. A lot of times it's going to look something like this. Here's your trinomial. And what you're trying to find is, if we factor it, you will get your answer in two binomials. So the answer of this is going to be x plus 1 times x plus 3. So what we learned in the last unit is how to multiply these together to get this. Factoring is undoing that. And let me tell you, the point of this, it all comes back to, remember the quadratic formula? Quadratic formula, what told you what x was? Well, if you have this as your quadratic, you know, that the function of a parabola here, you can factor it, and then I know that zeros for this are going to be -1 and -3. So when you factor it, it's actually a lot easier than doing the quadratic formula to find what your x values are, what your x-intercepts are, you know, when y is 0. So that's the point of factoring. Now let me just take a moment to tell you, when I first started teaching factoring, I taught 5 different methods, because depending on what the problem looked like, you would use different methods, and there's all these different tricks, and factoring was actually quite difficult. There's this saying among mathematicians that there are 2 F words in math. Yes, you heard me right. The first F word in math is fractions, and the second one is factoring. Like seriously, factoring is probably one of the hardest things ever. Until now. Until I bring you our handy dandy box method. So you will not be learning 5 different ways to factor depending on what type of problem you're given. With the box method, it works on every type of problem, and it's amazing and fantastic. Alright, so what I'm going to do is actually just go through a couple examples to show you how the box method works. So in class, all of the problems you're going to get are going to look like this. They're going to be trinomials, and the answer is always going to be 2 binomials. So the box we're going to use for our box method is always going to be a 2 by 2 box. Okay, so we make our 2 by 2 box. What we do next is this first term. Now remember, when we multiplied and we got this answer, where was this in the box? Our first term was where in the box? Remember, it was always this. We always had our x squared here to be our first term. And what was this? Wasn't this always the last term right here? So your first term you put in the first part of the box, and the last one you put here, because we multiplied, we always got that. And then when we multiplied, the middle term here was always where? Think about it. Where was it? Remember, these always added to it? We'd write our answer as x squared, and then this is our middle term, and that's our last term. So we're just doing it backwards now. First one goes in the first box, last one goes in the last box, and this middle one goes off to the corner here. So then what we do is we actually multiply these together. I take 8 times x squared, and I write that over here to the side. I get 8x squared. Now, this is why it's called factoring. We are trying to find factors. We're trying to find factors of this number that are going to add to 6x. Because remember, these two, whatever's in these 2 boxes, add to make 6x. So you're trying to think, okay, what are factors of 8? You have 1 and 8. And to get x squared, we take x times x. So 1x and 8x. The other thing that gets 8 is 2 and 4. So 2x and 4x to get the 8x squared. What else is factors of 8? What 2 numbers multiply to be 8? Nothing. Those are our factors. So which of these add to 6? Well, this adds to 9, and this adds to 6. So these are the 2 numbers that go in those boxes. And the order doesn't matter. Doesn't matter if you put 2x here or here. Who cares? That's kind of a nice thing. You don't have to worry about it. Just fill them in the empty boxes. And now we have our boxes filled. Okay, the next step is you look at this first row right here. Take out the greatest common factor, or take out what's common. So both of these have 1x. I'm going to take that out. See, this has 2x's, this has x squared, and this has 1x, so I can take out 1x. There's no numbers that they both have the same that I can take out. And then I fill in the outside of our box doing opposite what we did before. Remember, we take this times this to get x squared? So now I'm saying x times what is x squared? Well, x times x. And then I'm going to fill in this part of my box up here. X times what is 4x? Well, it's got to be times 4. And it would be a positive 4, right? You can put a plus there. Here, to get this 2x, you take x on top times what in front? Well, x times 2 is 2x. And then here's a cool thing. You always get to check your answer. This needs to be 8. 2 times 4 is 8. So that lets me know, oh, sweet, I did it right because 2 times 4 is 8. And that, my friends, is your answer. X plus 4, write in a binomial in parentheses. And then this is x, and that's a positive 2, so x plus 2. There is the answer. Pretty cool. Let's do another one. Okay, copy this down. Let's go ahead and do this one. It's always going to be a 2x2 box. First term in the first box. Last one in the last box. Middle off to the corner. Now you multiply these together, and I get 3x squared. Now think of factors. 1 times 3 is 3, and add the x's, because x times x to get x squared. And that's all the factors of 3. And they do add to 4. So 1x, 3x here. So that worked out. There's only one choice. That helps. Take out what's common in this first row. They both have an x. And then x times what up here gives you x squared. X times x. And x times what up here is 3x. 3. And then we're right here. What times x is 1x? Well, x times 1 is 1x. And then as you can see in the last box, 3 times 1 is 3. So I know I did it right. These are both positive, so I put a plus, x plus 3, and then x plus 1. There's our answer. Okay, now I'm going to write out the steps. So I'm going to write them out, and then you guys pause the video and copy down the steps. And you'll notice we aren't doing all the steps yet because we're not to the more complicated problems. Alright, here's all 7 steps of factoring. Now, before sometimes we skip like the first 3 steps because those problems aren't as complicated, and same here, except we actually skipped the first step. So like I said, factoring really is a lot easier than previous methods that were used, and it's not as hard as just it used to be. So in those 2 examples, we've already done steps 2 through 7. There wasn't a greatest common factor for us to take out yet. So in these notes, we actually won't be doing step 1 through the whole time. There won't be a greatest common factor, and I'll mention that as I go through, and then the next set of notes we'll do some of those problems as well. Go ahead and pause the video and copy these steps down, please. Okay, let's practice some more. What makes this one a little bit harder is we have a negative here. So before it was all positives, it was pretty basic. Now negative, we just have to be careful with the negatives. You can always use a calculator to check your work if you need to. So take out greatest common factor is if there's 1. So we have the number 1, 5, and 6. There's no greatest common factor, and not all of these have x's. And that's how it's going to be on all these. So there's nothing we can do for that step. Okay, first term in the first box, last term in the last box, middle term off to the corner. That's step 2. Step 3 is we multiply these together and write that to the side. Step 4, look for factors. So you have 1 and 6, and 2 times 3 are our 2 factors of 6. Which ones add to negative 5? Uh-oh, none of them add to negative 5. Well, that means these both have to be negative, right? And negative times a negative is a positive, but you add those to get negative 7. So a negative times a negative is a positive, but add these and you get negative 5. So if this is positive and this is negative, that means both the factors have to be negative. All right, so that's step 4. Step 5, put them in the boxes. And now we're on step 6. Step 6 is pull out the greatest common factor in this first row, which they only share an x. And then we fill the outside. Step 7, x times x is x squared. X times negative 3 is negative 3x. X times what is negative 2x? Well, x times negative 2. And then notice this last one is correct. To get 6, you take negative 2 times negative 3 is positive 6. So I did it right. So we get x minus 3 times x minus 2. There we go. Let's do some more practice with negatives. So first term, first box, last term, last box, and the middle one off to the corner. All right, multiply these together. I get negative 12x squared. Now I need to find factors that make negative 12 and add to negative 11. So you might think 3x and 4x, but one of them has to be negative. Well, if you take 3 plus negative 4, you're going to get negative 1. Switch the signs, you're going to get positive 1. We need 11. So what else makes 12? 6 and 2. One of them needs to be negative, though, because a negative times a positive makes this negative. Well, if you add these together, you're going to get either negative 4 or positive 4, depending on which one is negative. So the other factor of 12 is 12 and 1. It's an easy one to forget, 12 and 1. Now, they need to add up to be a negative number. That means the bigger factor is going to be negative. Negative 12 plus 1 gets you negative 11. Ding, 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 there's the right answer. So really the hardest part of factoring is trying to find which numbers fit in kind of this little puzzle. Multiply to this, add to this. Okay, I finally found it. So negative 12x and 1x. Doesn't matter which order you put them in. So this first row has x in common. X times x is x squared. X times 1 gives you 1x. Here, negative 12. So I have to take negative 12 times x to get negative 12x. And the last box, negative 12 times 1 is negative 12. So I know that I did it right. And then I write those as my binomials. Yay, there's the answer. Alright, go ahead and pause the video if you need to. Copy this down. First term in first box, last in the last. Middle off to the corner. Okay, don't forget to multiply these together. I get negative 20x squared when I multiply them. Factors of negative 20 that add to 8. So I think of 4 and 5 right away. 4x and 5x. One of them has to be negative, though, to make this negative. And if you add those together, you're going to get negative 1. Switch the signs, you're just going to get positive 1. So it's not 4 and 5. What else makes 20? I thought of 2 and 10. Okay, make one of them negative. Negative 10 times 2 is negative 20. If I add these together, I'm going to get negative 8x. Notice we need positive 8x. So if you get the right number, just the wrong sign, all you have to do is flip the sign. That means it's going to be negative 2 and positive 10. Right, those multiply to be negative 20, and those add to be positive 8x. So those are the numbers I want. And then put those in your remaining boxes. Alright, so what these have in common is an x. So x times x is x squared. X times 10 gives me 10x. X times negative 2 is negative 2x. And negative 2 and 10 make negative 20. Yes! It worked out. That lets me know I probably did it correctly. That's my answer, and that is factoring. So I want you to practice this type of factoring. So that's going to be 1 through 7. Practice 1 through 7. It's the ones without a coefficient in the front. When there's this coefficient, we haven't done ones like that yet. So 1 through 7, and then go ahead and do 20 through 22 through 24. Okay, practice those before you watch the second video. Make sure you have the basics of factoring down before it gets more complicated. So do 22 through 24, 1 through 7. Check your answers before the next video. Thanks, everyone.